Carbon surrounded only by single bond or sigma bond is known as what? sp3 hybridized carbon. If the OH group is attached to the aliphatic carbon chain, then that class of organic compound is called as alcohol. Alcohols are classified into 4 categories based on number of OH group present in the molecule. What is functional group? Functional group is an atom or a group of atoms which gives a characteristic property to an organic compound. Hello my dear students, I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Welcome to 7th chapter of your 2nd PU syllabus, Alcohols, Phenols and Ethers. Alcohols, Phenols and Ethers. In that, today I am going to take the first session of the chapter, Alcohols, Phenols and Ethers. In this session, I am going to give definition for alcohols, classification of alcohols, classification of monohydric alcohols and nomenclature of alcohol. That is, in session 1, I am going to give introduction and classification and nomenclature of alcohols. Definition for alcohols. Now, in this chapter, we have to deal with 3 organic compounds like alcohol, phenols and ethers. As you know that organic compounds are classified into different categories based on functional group. What is functional group? Functional group is an atom or a group of atoms which gives a characteristic property to an organic compound. Based on functional group, organic compounds are classified into different varieties like haloalkanes, haloarenes, alcohols, phenols, ethers, aldehydes, ketones, carboxylic acid, esters, acid amides, acid halides, etc. In this chapter, we have to study about 3 organic compounds like alcohol, phenols and ethers. Alcohols and phenols are hydroxy derivatives of hydrocarbons. Alcohol, phenols are hydroxy derivatives of hydrocarbon. Ethers are the alkoxy or aryloxy derivative of hydrocarbons. Alcohols and phenols are hydroxy derivative of hydrocarbons. Ethers are alkoxy or aryloxy derivative of hydrocarbon. Alcohol, phenols and ethers have wide range of application in our daily life. Alcohol, first one, alcohols are used as solvent for many organic compounds, and starting from alcohol, one we can prepare other class of organic compounds. Phenols are used as adhesives as well as antiseptics. Adhesives as well as what? Antiseptic. Ether is used as a solvent for many organic reaction. In that, diethyl ether used as surgical anesthetic. Used as surgical anesthetic. My dear student, which ether is used as surgical anesthetic? Diethyl ether. Therefore, alcohol, phenols and ethers have wide applications in our daily life. Alcohols are used as solvent for many organic reaction, as well as from alcohol one we can prepare other class of organic compounds. Phenols are used in the manufacture of adhesives as well as antiseptics. Ethers are used as a solvent for many organic reaction. Alcohols and phenols are hydroxy derivatives of hydrocarbon. Ethers are alkoxy or aryloxy derivative of hydrocarbon. Now, first one, let us consider alcohols. Already I mentioned these are hydroxy derivatives of hydrocarbons, but in which the OH group is attached to the aliphatic carbon chain. If the OH group is attached to the aliphatic carbon chain, then that class of organic compound is called as alcohol. Once again, I'll repeat the definition of alcohol. Alcohols are hydroxy derivatives of hydrocarbons. Alcohols are hydroxy derivatives of hydrocarbon, in which OH group group is attached to the aliphatic carbon chain. Aliphatic carbon chain. The general formula of alcohol is ROH. General formula of alcohol is ROH, where R is alkyl, alkyl, or aralkyl. R is alkyl or aralkyl, aralkyl, or vinyl group, or vinyl group. Therefore, what's the general formula of alcohol? ROH. If I put R is equal to CH3, it is methyl alcohol. If it is R is equal to CH3CH2, that is C2H5, C2H5, it is known as what? Ethyl alcohol. Methyl alcohol, IUPAC name is methanol. Ethyl alcohol, IUPAC name is what? Ethanol. Methyl alcohol as well as what? Ethyl alcohol. So, alcohols are hydroxy derivatives of hydrocarbon in which OH group is get attached to the aliphatic carbon chain. Now, this classification of alcohols. Alcohols are classified into 4 categories based on number of OH group present in the molecule. Number of OH group present in the molecule. Based on the number of OH group present in the molecule, alcohols are classified into 4 classes. They are monohydric alcohols, dihydric alcohols, trihydric alcohol, as well as polyhydric alcohol. What are the 4 classification of alcohol? Monohydric alcohol, second one is dihydric alcohol, third one is trihydric alcohol, fourth one is polyhydric alcohol based on number of OH group, based on number of OH group, based on number of OH groups, they are classified into 4 categories: monohydric alcohols, dihydric alcohols, trihydric alcohols, as well as what? Polyhydric alcohol. Let us consider monohydric alcohol. In the name only it has term mono. Mono means one. The alcohols which containing only one OH group, they are called as monohydric alcohol. They contain only one hydroxyl group. Very beautiful example for monohydric alcohol, methanol and ethanol. Methanol and ethanol. What's the formula of methanol? CH3OH. What's the formula of ethanol? CH3CH2OH. CH3CH2OH is the formula of ethanol. Ethanol and methanol are the beautiful example for monohydric alcohol. But next, dihydric alcohols. These compounds contain only how many OH group? When alcohol contain 2 OH group, they are called as dihydric alcohol. Example for dihydric alcohol is ethylene glycol. Ethylene glycol. Ethylene glycol. Ethylene glycol is its trivial name, IUPAC name. If I number this as first carbon and this as second carbon, 2 carbon atom are there, therefore it is known as ethane. And first and second position, there is a presence of OH group, ethane 1,2 diol. Ethane 1,2 diol, and its trivial name is ethylene glycol. Ethylene glycol. Next, trihydric alcohol. Trihydric alcohols are those which containing 3 OH groups in the molecule. Example is glycerol. Example is glycerol. Glycerol. Glycerol, IUPAC name is the structure of glycerol. So, CH2OH, CHOH, CH2OH. If I number 1, 2, 3, 3 carbon atoms are there, therefore propane, 1, 2, 3, triol. 1, 2, 3, triol. Okay. Next, polyhydric alcohol. Polyhydric alcohols are those which containing more than 3 OH group. More than 3 OH group. Example for polyhydric alcohol is sorbitol. Yadu example yadu polyhydric alcohol ge sorbitol. Sorbitol is an example for polyhydric alcohol. Polyhydric alcohol. Next, classification of this monohydric alcohol. Monohydric alcohols are classified into 2 types based on OH group is attached to which type of carbon. On that basis, it is classified into 2 groups, where in the first case, the OH group is attached to the sp3 hybridized carbon. OH group is attached to the sp3 hybridized carbon. In the second case, OH group is attached to sp2 hybridized carbon. Therefore, depending upon the nature of the carbon atom, the monohydric alcohols are classified into 2 classes. First one, compounds containing OH group in that the OH group is attached to the sp3 hybridized carbon. sp3 hybridized carbon. Next, compounds containing OH group in which OH group is attached to sp2 hybridized carbon. First one, compounds containing OH group on sp3 hybridized carbon. sp3 hybridized carbon. Monohydric alcohol may be further classified according to the hybridization of the carbon atom to which hydroxyl group is attached. First one, compounds containing OH group on sp3 hybridized carbon atom is attached. sp3 hybridized carbon atom is attached. So now, when the OH group is attached to sp3 hybridized carbon, they are further classified into three types: saturated aliphatic monohydric alcohol, allylic alcohols and benzylic alcohol. Saturated aliphatic monohydric alcohols, allylic alcohols, benzylic alcohol. Therefore, compounds containing OH group where the OH group is attached to sp3 hybridized carbon is further classified into three types: saturated aliphatic monohydric alcohol, allylic alcohol and benzylic alcohol. First, let us consider saturated aliphatic monohydric alcohol. In this alcohol, OH group is attached to alkyl group. OH group is attached to alkyl group. If OH group is attached to alkyl group, then that class of alcohol is called as saturated aliphatic monohydric alcohol. Alkyl group is R. If O is attached to R, R is CnH2n plus 1. CnH2n plus 1. How can you get alkyl group? Alkyl group is obtained by removing one hydrogen atom from respective alkane. For example, what's the molecular formula of methane? CH4. If you remove one hydrogen atom from methane, it will become CH3. Then it is known as methyl. Ethyl is C2H6. C2H5 is ethyl. Ethane is C2H6. Ethyl is C2H5. Propane is C3H8. Propyl is C3H7. Like that, if the OH group is attached to alkyl group, then that is called as saturated aliphatic monohydric alcohol. This saturated aliphatic monohydric alcohol further classified into three types: primary alcohol, secondary alcohols as well as what? Tertiary alcohols. What are primary alcohol? In this alcohol, OH group is attached to primary carbon. It is OH group is attached to primary carbon atom of alkyl group. What is primary carbon? Primary carbon is a carbon which is attached to one adjacent carbon atom. If carbon is attached to only one adjacent carbon, it is known as what? Primary carbon. Therefore, the functional group of primary alcohol is CH2OH. General formula is RCH2OH. RCH2OH. Example, methyl alcohol and ethyl alcohol. The best example for primary alcohol is methyl alcohol and ethyl alcohol. Next, secondary alcohols. Here also, in these alcohols, the OH group is attached to the secondary carbon of alkyl group. Secondary carbon of alkyl group. What is secondary carbon? Carbon atom bonded to two adjacent carbon atom. Carbon atom bonded to two adjacent carbon atom. They are called as what? Secondary. The functional group is CHOH. Functional group is CHOH. General formula is RCHOHR. That means it has how many alkyl group? Two alkyl group. In the place of R, if I put two CH3 group, it is known as what? Isopropyl alcohol. It is known as what? Isopropyl alcohol. Third one, tertiary alcohol. In this alcohol, the OH group is attached to the tertiary carbon of alkyl group. Tertiary carbon of alkyl group. What is tertiary carbon? Carbon atom is bonded to three adjacent carbon. Three adjacent carbon. It is known as tertiary carbon. The functional group of tertiary alcohol is C attached with OH. Other three valencies are satisfied by R. Other three valencies are satisfied by 3R. Therefore, CH3, 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 OH. Tertiary butyl alcohol. Tertiary butyl alcohol. Tertiary butyl alcohol. Next classification, allylic alcohols. In this alcohol, the OH group is attached to allylic carbon. OH group is attached to allylic carbon. If OH group is attached to allylic carbon, it is called as what? Allylic alcohol. What is allylic carbon? Allylic carbon is a sp3 hybridized carbon which is attached to the carbon-carbon double bond. Which is attached to the carbon-carbon double bond. See here, it is allylic carbon because it is sp3 hybridized. How can you say it is sp3 hybridized? Carbon surrounded only by single bond or sigma bond is known as what? sp3 hybridized carbon. My dear student, what's the definition for sp3 hybridized carbon? Carbon which is surrounded by only single bond or sigma bond, it is called as what? sp3 hybridized carbon. If this sp3 hybridized carbon is directly attached to the carbon-carbon double bond, if it is directly attached to the carbon-carbon double bond, it is called as what? Allylic carbon. See here, OH group is attached to sp3 hybridized carbon, this carbon, which is attached to carbon-carbon double bond, it is called as what? Allylic alcohol. In allylic alcohol, they are further classified into three types: primary, secondary, tertiary. See here, this carbon is attached with 2 more carbon, this carbon is attached with 3 more carbon, this carbon is attached with only 1 carbon. Remember, primary carbon means which is adjacent to 1 carbon, secondary carbon means which is adjacent to 2 carbon, tertiary carbon means it is attached to 3 adjacent carbon. Next, benzylic alcohol. Here, the OH group is attached to benzylic carbon. OH group is attached to benzylic carbon. What is benzylic carbon? Benzylic carbon is also sp3 hybridized carbon which is directly attached to the benzene ring. Which is directly attached to the benzene ring. These are the alcohol in which OH group is attached to sp3 hybridized carbon next to the aromatic ring. sp3 hybridized carbon next to the aromatic ring is called as benzylic carbon. Is called as benzylic carbon. So this is called as benzylic carbon because it is next to the, it is directly attached to the benzene ring. In this also we have three types: primary, secondary, as well as what? Tertiary. As well as tertiary. Next, compounds containing OH group to which sp2 OH is attached to sp2 hybridized carbon. In that, the first vinylic alcohol. What are vinylic alcohol? Here the OH group is directly attached to the carbon-carbon double bond. Carbon-carbon double bond of aliphatic chain. Observe here, the OH group is attached to carbon-carbon double bond of aliphatic chain. The example is vinyl alcohol. Example is vinyl alcohol. Therefore, it's a classification of, I completed the classification of monohydric alcohol. Next, after classification, you have to learn about nomenclature of alcohol. Already you know that in case of organic chemistry, organic compounds are named by two systems. One is trivial system, or also it is called as common system. Second one is IUPAC system. In common system, alcohols are named by adding the word alcohol after the corresponding alkyl group. Example, if it is CH3OH, CH3 is methyl, you can read as methyl alcohol. C2H5OH, you can read as ethyl alcohol. But in IUPAC system, alcohol are derived from corresponding alkanes, replacing E of alkane by OL. The suffix is OL. Suffix is OL. Any organic compound whose name is end by OL, then it is called as what? Alcohol. Then it is called as what? Alcohol. Now, how to name alcohol in IUPAC? The longest continuous chain containing carbon bonded to the OH group is selected as the parent chain. First, you have to select parent chain. In that parent chain, OH group must be present. The carbon atoms in the chain are numbered in such a way that carbon atom carrying OH group, hydroxyl group, should get the least number. The least possible number should be given to the functional group. What's the functional group of alcohol? The functional group of alcohol is OH. The position of substituent is indicated by suitable number. The alcohol with 2 OH group is named as diols. Alcohol with 3 OH groups are named as triol. Cyclic Cyclic alcohols are named using the prefix cyclo, considering the OH groups attached to the carbon of the ring as C1. These are the rules for naming alcohol in IUPAC nomenclature. Observe here, CH3OH, methyl alcohol, common name, IUPAC methanol. CH3CH2CH2OH, common name is N-propyl alcohol. IUPAC name is, if I number this as 1, 2, 3, propane 1-nol, propane 1-nol. Next, it is a common name is isopropyl alcohol. If I number like this 1, 2, 3, it is propane 2-ol. So if I number 1, 2, 3, 4, it is butane 1-nol. Common name is N-butyl alcohol. If I number 1, 2, 3, 4, butane 2-ol. Butane 2-ol. Common name is secondary butyl alcohol. Next, so if I number 1, 2, 3, it is 2-methyl propane 2-ol, tertiary butyl alcohol. If I number 1, 2, 3, it is glycerol, propane 1, 2, 3, triol. It is cyclohexanol. It is 2-methyl cyclopentanol. If I number 1, 2, 3, 4, 5, 6, it is 4-chloro-2,3 dimethyl pentanol. Okay. Next, structure of alcoholic functional group. In alcohol, the oxygen of OH group is attached to sp3 hybridized carbon by sigma bond formed by the overlapping of sp3 hybrid orbital of carbon with a sp3 hybrid orbital of oxygen. So, the sigma bond is formed because of the overlapping of sp3 hybrid orbital of carbon with sp3 hybrid orbital of oxygen. The figure shown below, it is a structure of methanol. The bond length of CO and OH is 142 picometer and bond angle is less than 109 degree 28 minutes. It is equal to 109.5 degree because of the repulsion between lone pair and bond pair. The LPBP repulsion, that is repulsion between lone pair and bond pair. There is a repulsion takes place between lone pair and bond pair. The usual bond angle is 109 degree 28 minutes. It decreases to 108.5 degree. So therefore, there is a distortion of the geometry. So this is about the structure of alcoholic functional group. Therefore, my dear student, today I completed definition to alcohol, classification of alcohol, as well as what? Nomenclature of alcohol. In the next session, I am going to discuss about how alcohols are prepared from alkenes, from carbonyl compounds, as well as from Grignard reagent. My dear students, next session I will come up with how alcohols are prepared from alkenes, carbonyl compounds, as well as what? Grignard reagent. Until that, goodbye. Thank you. Take care.